So we have a question here that looks very similar to question 6 you have on your homework assignment. How much would you have to put aside each year at 7.2% compounded annually to have $80 in 3 years? So this concept is coming to us from chapter 11. And the specific formula we're going to deal with is formula 11.1a. And let's take a look at what that formula looks like. We've got our payment. Oops. Equals the future value times the interest rate over 1 plus the interest rate to the power of n minus 1. And let's see what we're putting in here. According to our information we have, we're given the future value. Future value equals 80. We also know the interest rate, 7.2%. And we know the number of compounding periods. Oops. N equals 3. So keep those in mind. And then let's take a look at how we'd have to calculate this. So our payment equals the future value, which we know is 80, times 7.2% divided by 1 plus 7.2% minus 1. So that's fine and dandy. Let's look at how we get that into our calculator. I'm going to start with what's in the top here, the numerator, 80 times 7.2%. See what that is. We don't want to take it out of our calculator, but we're going to keep it. I'm going to put it in register 9, STO9. The BA2 Plus has 9 or 10 places where you can store things. And in this case, I'm just going to keep that there and then do what's in the numerator. So the numerator, I'm going to start with the 7.2, hit the percent, plus 1, see what that equals. Don't take it out of the calculator. Then we need y to the power of x, and that's 3. See what that's equal to. don't take it out of the calculator. Then go minus 1 equals, and see what that is. So now we've got everything in the numerator, and I'm going to see what, oh, we know what that is, minus 1, and I'm going to store it, STO register 6. So then what I can do is I can go recall 9 divided by recall 6 equals, and I end up getting 24.83558884. But of course, we're talking about money here, so we only want 2 decimal places. 24.84. So that's all fine and dandy, but let's go and see if we can figure out how to do this in Excel. So we have our calculations here. Now notice we've solved for future value, present value, rate. We haven't tried solving for the payment yet. So, oops, that didn't work at all. Payment equals, and it's going to be equals PMT bracket, and we can see that we're looking for rate, number of periods, present value, future value, and type. So let's make a note of those, because we're going to want to type them down here. So rate, number of periods, present value, future value, and type. And so we're going to want to put in this space, this space, this space, this space, and this space. Excel is confused at the moment. So rate, in per, present value, future value, and type. So let's fill in something we know here. We know this is 7.2%. The number of periods we know is 3. The present value, we have nothing. In other words, there's no money in this account before we start. And the future value is 80. And that's the amount of money we're going to get. So it's a positive number. And the type here is going to be 0, because we're assuming it's an ordinary annuity, even though in the question we weren't actually told, but we're assuming it's an ordinary annuity because we weren't told it was a annuity due. So this is question number 6. So let's save all that nonsense. And we're being told that we'd have to make a payment of $24.84, and Excel makes it negative because of the cash flow concept. That's the amount of money we have to put in to the investment. And so let's Control V here and 2484, and we can see that it's exactly the same numbers we got with our calculation, although the cash flow concept says it has to be negative, which makes perfect sense because we have to put the 2484 into the investment. It has to come out of our pocket, and eventually we'll get $80. That's positive. It's coming into our pocket. So hopefully that works. Let's stop that. Stop recording.